Welcome back, Natural Resources. We are finished up with the forestry unit, and now we are going to start looking at soil, water, and air resources. This will be kind of lengthy as far as the soil part because there's a whole lot that is involved um, in having a good soil, and there's a lot involved in things like erosion and stuff like that. So I'm actually going to break this soil section up into two different parts. One, we're more or less going to be looking at soil formation and soil profiles, and then we'll actually go into the judging of soil. There is a land judging competition that is held by FFA that we use to help judge different types of soil, whether it's sandy, clayey, loamy, whether it's good for farming, whether it's good for building on. Kind of just depends on the soil itself, where it's located, and the properties that it has. Unfortunately, that competition is not being held this year, but maybe eventually, maybe we'll have a chance to take part in that competition. So the first thing we're going to take a look at is the actual definition of soil, and we're really just looking at the layer of natural materials that is on the Earth's surface. Contains both organic, meaning something that has lived or is living, and inorganic, which rocks, minerals, things like that, and is capable of supporting plant life. So we don't want to call it dirt, and I know that a lot of times we talk about the dirt, but if you're really talking about the substance that is beneficial and useful, we want to call it soil. When we talk about dirt, we're talking about things that are, on the floor, that are not beneficial, not useful. Something that's beneficial and useful, we want to call it soil. An ideal soil is going to have about 50% solid materials, whether that's organic or inorganic, and about 50% pore space. And of that 50% pore space, ideally, you want to have about half of that full of water and about half of that full of air, because the plants and the roots need to have both the water and the air in order for them to be able to survive and thrive. Major soil parts. Let's look at some inorganic matter to start with. These are the minerals. These are the things that are not living, have not been living. They come from rock parent material typically. There's three different sizes of materials, and you've got sand, silt, and clay. If you look all the way at this picture, all the way to the left, you see gravel. And obviously, we're looking at things like rocks there. But if we were to compare the sizes of a grain of sand to the size of a grain of clay, it's very difficult to be able to do it, because you can actually pick out a single grain of sand. You go to the beach and pick up a handful of sand, you can pick out one grain, but you can't actually do that with clay. So the size of these particles, a lot of it has to do with how much water they can hold, how much air they can hold, has to do with the size of the particles themselves. If you have a lot of these sand particles and they're up against one another, because they are so big, there's going to be a lot of space for air. There's going to be a lot of space for water, meaning that water is going to flow through it fairly quickly. If you think about going to the beach and waves come crashing in on the shore, it doesn't take long before the water has dissipated. When you get to something as small as clay, they are going to fit much more tightly together. And because of that, most of the time you don't have actual soaking in of the water. A lot of times you have runoff and issues with things like flash flooding. So that's why in the western part of the state, we have some issues with flash flooding because of water runoff. Now, in the eastern part of the state, where there's flooding, typically that has to do with the fact that they are so much closer to sea level than what we are. But the sand and the soil and the silt also, or the sand and the silt and the clay also do play a factor on that. So as far as sand, you're looking at the largest particle. If you have a lot of sand, it's going to drain very, very quickly. Where I grew up in the eastern part of the state, most of the soil that was there at least had a topsoil that was sandy, and it did sink down into the soil fairly quickly. Where I was, we had enough silt and what we call loamy soil that it did make for a good fertile farmland, but the further you went east, the more in that coastal region, it just doesn't hold water or nutrients. Silt is going to be the medium. A lot of times you see this by streams. Typically, this is going to be kind of a doughy feel, a powdery feel to it. It has a much higher nutrient holding ability. Silt is going to be more ideal for planting things. Normally, whenever you have a silty type soil, it doesn't have any stickiness to it like you sometimes feel with clay, and that's why it's doughy or powdery feeling. It's just kind of this muddy feel that does not have a stickiness to it. Clay, this is what we think of when we think about this part of the state. Red soil, and that red soil is going to have, it's going to be a small particle, but it's also going to have a stickiness to it, especially when it's wet. That was one thing for me. It was an adjustment when I moved to this part of the state, because growing up in the sandy part of the state, we didn't have red clay. And so when I went outside, I didn't have to worry about my shoes turning up muddy or sticky or red or clayey. I didn't have to worry about dragging red clayey stuff everywhere. So that's something that, it has been an adjustment for me since I moved out here. Of course, that's been a long time ago, but it is a much different type of soil in this part of the state. It does cling together better because those particles are so small, but often it does have a little bit of a sticky feel to it. And it's going to drain really, really slowly because those particles do cling so tightly together. As far as the water, the soil particles are going to hold the water in between them and around them in order for plants to be able to use them. We're going to look at some different forms of water. We will talk more about water in the next section, but we will talk very briefly about it and how it relates to soil here for just a few minutes. But in the next section, we'll really be talking specifically more about water. But the water itself is so very important to plant growth, and the ability of each soil to be able to hold water makes such a difference in what you can actually do with that water. The best soil is going to be something that will drain, but not drain as quickly as sand, that the water doesn't run through it so quickly that it doesn't actually hold the water or nutrients. You do want it to hold some water, but you don't want it to run off the way a clay does or run through it like it does with sand. So something that has some silt form to it is what's going to be ideal as far as water. There's different types of water. You've got the gravitational water, and that's the water that actually drains downward. I mean, we're looking at the gravity pulls us down. Gravity holds us down to the ground. And so as it is being pulled down through those soil particles, that is gravitational water. Sometimes the water just kind of sticks around and it stays in between those soil particles and it doesn't really try to move anywhere. And that is going to be your capillary water. And then you've got hygroscopic, and that's going to be around in between those soil particles. And then you have the hygroscopic water that actually sticks to each particle. So the gravitational water is going to be the one that moves most quickly. And then probably the one that's going to be released second most quickly is going to be capillary. And then, of course, your hygroscopic water is going to be what's going to stick to those soil particles best. Okay, we want to make sure that we have air in between soil particles because plant roots need air as well. If they don't get enough air, then they're not getting the oxygen that they need in order to be able to perform the way that they're supposed to. So ideally, you want to make sure that you've got about 50% water and 50% air in the pore space. But you do want to make sure that you do have some air, that it's not drowning. Many times when we think about plants drowning, we water too much. That's one thing that is a concern sometimes with horticulture classes, because we're all told you need to make sure that you need to water your plants. And yes, you do need to water plants, especially if they're going to be dried out in between. But if you water them and you drown them every day, you completely soak them every day, a lot of times you don't have enough pore space for that air to be able to get to the roots, and you end up actually drowning the plants or causing the roots to rot. So you want to make sure you've got some air in between those soil particles. Now, as far as the organic matter, this is extremely important. We have lots of minerals. We have the mineral particles of the sand, the silt, and the clay. But the organic stuff is what makes the soil so nutritious. Whenever we are looking at organic matter, we're looking at things that have decayed, are decaying, or will decay. So we're looking at roots. We're looking at the carcasses of insects. We're looking at worms. We're looking at things that are in the soil that are going to add nutrient factors to it. Well decomposed soil or well decomposed organic matter is called humus. And soils that have got a lot of humus are going to be really, really high in fertility. A lot of times, the darker the soil is, the more humus it has in it. So we want to kind of look at the color of soil, and that color of soil does help to make a difference in what's going on inside that soil and how nutritious that it actually is. Typically, when we think about these living organisms, they're not actually considered a part of the soil until they actually die and start to decay. You can see some pictures here of some earthworms. They can't actually be part of the soil until they become part of the soil. So as long as they are living, that's their habitat. But then once they die and they start to decay, they become an organic part of the soil. So soil formation takes a long time. This is not a process that's going to happen fairly quickly, and it's going to be influenced by several different things. Parent material is one, and that's what the soil is actually going to be made of. It's what it's going to start from. Typically, you're looking at larger rocks and larger rocks and gravel that will eventually be broken down into smaller inorganic particles. And a lot of the way those are broken down is by climate. The temperature, the weather, the how much rain that you're actually getting, the heating and the cooling, and the climate makes a big difference on how quickly that parent material is going to be broken down. Living organisms also make a big difference because the more stuff living in the soil, the more likely you are to have things that are going to break down. Topography makes a difference. Low-lying land versus mountainous type land. And then, of course, time. It's going to take a long time for things to actually break down into a newly formatted soil. The parent material is just that mass of mineral and organic matter from which the soil is formed. We talked about that a few minutes ago. You can see in this picture, there's a line, and that line kind of goes right along in here. And this part down here looks very, very rocky, whereas this part up here looks a little bit more smoothed out. And this rocky part down here is what's going to be your parent material that will eventually break down into your smaller soil particles. This picture here just kind of talks a little bit about climate, precipitation, temperature, wind. All these things play a role in how quickly soil actually breaks down. It also plays a role in how quickly soil particles move. So we will eventually look at erosion and the factor that climate, the role that climate plays on erosion. Living organisms, we just mentioned living organisms, but they do help to break down parent material because you think about it as these roots, not so much with grass roots, but tree roots and things like that. As they burrow down into the soil, they're eventually going to burrow down into that parent material. And as they burrow down into that parent material, it helps to break it down and turn it into something that is a more usable soil. Topography is just, we're looking at the formation of the earth. We're looking at mountains versus flatlands versus hills versus swampy areas. Steeper terrains are not going to build soils up as quickly as flatter terrains, just because it runs off whenever it gets rained on. And so in the flatter areas, it has a chance to kind of settle in one spot and just stay in that one spot. And then, of course, time. Everything takes time. Soil is not one of those things that's going to be created overnight. It takes quite a bit of time for it to actually form and become a soil profile, which is what we're actually going to look at next. We're going to finish up this first part by looking at soil profiles. And if you were to actually dig a hole, typically you would see these different parts of soil in that hole. And I'm hoping that as we come back, those of you who are in cohort A and B, as we come back, that we can start looking at some soil formation, and we can look at some soil profiles. We get the soil tube and take a look at it. You might have an organic layer on the top where you have things that are living, have living, or decayed. In that very first horizon, where if you have that, then we call that the horizon O, or the O horizon for organic material. Typically, we start though with thinking about the A horizon, which is going to be your surface soil. This is going to be the most broken down into parts, the smaller soil particles. Next, you're going to have subsoil, and the subsoil is going to be not quite as broken down as what you're going to see in that topsoil, but you will see more rocks and things in that. And then as you become further and further down, you start having more rocks, and then you get into the bedrock or parent material. And we just mentioned the things that are on this slide. So I'll give you a couple of seconds to pause this if you want to write that down in your course pack, but we have just talked about that, so I'm not going to go over it again. Okay, and lastly, we are going to start looking at this tomorrow, or in the next PowerPoint, or in the next section of the PowerPoint. It's actually classifying soils, and so this is kind of a little bit of a preview of what we're going to be looking at. I told you that there is a land judging competition, and in order to do the land judging competitions, you have to know several things about a soil. We look at the texture, we look at how deep the soil is, we look at the color of it, we look at the structure, how it's put together, the consistency of it, what it feels like, and permeability, how quickly water and air would actually flow through that soil. So that's next time, whenever we're going to be looking at how to actually judge a soil and know what it's going to be good for. So for now, we'll take a little break, and then we'll be here next time looking at soil classification.